Hello and welcome back to lesson 3.3 on measures of position. In this lesson, you're going to learn about standard scores, standardized scores, z-scores, percentiles and how to find them, how to find the upper and lower fence, the IQR, I didn't add that, and outliers. So formally outliers. Okay, the z-score is the first thing. It's our standardized score. The average number of standard deviations in observation is either above or below the mean. We can use a z-score, which is the number of standard deviations a value is away from the mean to use as a comparison. So have you ever heard your parents say, you're not comparing apples to apples or oranges to oranges, you're comparing apples to oranges? That happens sometimes where you're comparing the height of, let's say, men and women. On average, males are taller than females. And so they're not comparing oranges to oranges. You're comparing apples to oranges. So we want to use a z-score to put them on a standardized scale. So after we calculate our z-score, we want to decide what is considered an unusual observation. We talked about this in the last lesson, right? Any observation that is either above or below the mean by 2 standard deviations. So that means if your z-score is less than or equal to a -2, which means you fell below the mean, or greater than or equal to a +2, you fell above the mean, then you're considered unusual. So let's look at example 1. It says 2 students, John and Ali from different high schools, wanted to find out who had the highest GPA when compared to his high school. Which student had the highest GPA when compared to his high school is the question. So first, we have to find the z-scores to be able to compare that, because it looks like their mean from their high schools are calculated differently. Like their GPAs are must be on a 4-point scale for John and maybe on 100%, a 100-point scale for Ali. So we have to calculate their z-score to put them in a relative comparison to one another. So let's find their z-scores. I'm going to take John's score and subtract the mean, and then divide by the standard deviation. And we get a -0.21. So he has a lower GPA than his average by 0.21 standard deviations. Ali, when we find his z-score, he is below the mean by 0.3 standard deviations. So that means John is closer to the mean, a little bit higher. John has a higher GPA relative to his peers. Let's look at the next example is looking at swim times. So when you're looking at GPAs, you want to have a higher GPA. That means you're smarter, or you're studying harder in school. You're performing better in school. When we're looking at swim times, you want to have a lower swim time. That means you're faster. So it says 2 swimmers, Angie and Beth, from different teams, wanted to find out who had the fastest time for the 50-meter freestyle when compared to her team. Which swimmer had the fastest time when compared to her team? Okay, so Angie and Beth, we have their individual times, the mean time, and the standard deviation. So let's calculate their z-scores. I'll let you calculate and then pause the video, calculate your z-scores, and then come back and compare with what I have. Okay, welcome back. I'm going to calculate Angie's and Beth. So Angie is a -1.25 faster than the mean. And Beth is a full 2 standard deviations less than the mean. So we want the one that's further away. So Beth is faster by 0.75 standard deviations. So another important attribute to look at for data is measures of location. So measures of location, some examples are quartiles or percentiles. Quartiles have the word quart or quarter inside there, so meaning 25% groups. Sometimes we want to find other percentages besides the 25%, 50 and 75, and so we're going to look at just general percentiles. Percentiles are labeled P sub K, where K is the percent of the data that falls below P. Okay, so remember, we have to remember that it's the percentage of the data that falls below P. So the median is a number that measures the center of the data. You can think of the median as the middle value, but it does not actually have to be one of the observed values. The median is our Q2 because it's our middle 50%. Our other quartiles are 25th percent quartile, that is Q1, where 25% of the data is below that value. And then Q3 is our 75% of the data is below that value. We are going to use the Q3 and Q1 to calculate the IQR. So the IQR is the interquartile range. It's a number that indicates the spread of the middle half or the middle 50% of the data. It is the difference between the third quartile and the first quartile. So it tells us where the middle 50% of the data is. So once we calculate the IQR, we're going to use that to calculate a lower and upper fence. The lower fence takes the Q1 and subtracts 1.5 times that IQR. The upper fence takes the Q3 and adds 1.5 times the IQR. So they're different calculations because we're using the Q1 here and the Q3 here. So once we know the lower and upper fence, we can decide if a value, a data point, is an outlier if it's below the lower fence or above the upper fence. Then we would consider it a potential outlier. The IQR can help determine potential outliers. A value is suspected to be a potential outlier if it is less than, like I said, less than the lower fence or bigger than the upper fence. So example 3 here, we have 13 real estate prices. We're going to calculate the IQR and determine if any prices are potential outliers. Prices here are in dollars. And we ordered our solution here is we're going to order our data from smallest to largest. M is our median. We have our Q1 and our Q3. So our median is right here. So our Q1 is 1, 2, 3, 4, 5, 6 data points. So to find our Q1, we'd have to average the two in the middle. So we're going to average these two. So we average those and we get the Q1 here. And then the Q3 is going to be averaging these two in the middle up above the median. And we get 649,000. And then to find the IQR, we take the difference between the Q3 and the Q1, and we get 340,250. So the lower fence is taking Q1 and subtracting 1.5 times my IQR, and I get a negative 201,625. And then my upper fence is my Q3, and I'm going to add 1.5 times my IQR, and I get 1,159,375. So we're definitely not going to have any houses that are less than 0. So the lower fence is not going to be a likely spot to find any outliers here. However, we do have a home price that's 5.5 million, and it is more than our upper fence. And so therefore 5.5 million is a potential outlier to consider. Example 4, I'm giving you a chance to try these on your own. I'm asking you to find the Q1, Q2, Q3, and IQR, and then determine if any test scores are outliers by using the upper and lower fences for Class A and Class B. So for Class A, you could rewrite them smallest to largest. You could also put them into Desmos. So what I did was, I'm going to share my screen so you can see. I put them into Desmos. And if you click on my Desmos link, I put Class A in X1 and Class 2, I'm sorry, X2, and Class 2, Class B is in Y2. And then the stats command gives you your minimum value, your Q1, your median, which is your Q2. It gives you your Q3, and then also your max. So the stats command is really helpful. And then we can take our Q3 and Q1 and find our IQR. So for Class A, my IQR is 18. And then down here, I found my IQR of Class B as 21. And I'm documenting these on my notes page, so I suggest you do the same. And then for A, okay. So for my lower fence for Class A, we have 72.5 subtracting the IQR times 1.5. And so we get a lower fence of 45.5. And the upper fence is 90.5 plus 1.5 times 18 is 117.5. And then let's go ahead and calculate the lower and upper and lower fence for the Class B. Class B has the same Q1, although the IQR is different. So the lower fence is 41, and then the upper fence is 125. And I'm going to go back and show you my paper here. So I wrote out the LQRs, then I wrote out the lower fences for each and the upper fences for each. And it does not look like there's any data that's below the lower fence or above the upper fence for either of them. So it doesn't appear to have any outliers. Reach out if you have any questions on that. Next up is finding percentiles. So if you want to find a percentile for a data set, you can find them. I'm sure there's ways to find them in Desmos, but I'm going to show you how to find them by hand so that you understand how it works. So if you want were to do a little research, you can find several formulas. We're going to use a different one here that I've just chosen to follow. There's a couple different ways to find this. So K is going to be the kth percentile that you're looking for. It may or may not be an actual data point in your data set. I is the index, so it's the ranking position of your data value from smallest to largest. N is the total number of data points. You're going to order your data from smallest to largest and then calculate I. I is K out of 100 times N plus 1. If I is an integer, then kth percentile is a data value in the ith position. If I is not an integer, then you're going to round up. Round I up and round down to the nearest integers. Average the two data values in those two positions in the order data set. So let's look at an example. We have 29 ages for Academy Award winning Best Actors in order. So smallest is 18, largest is 77. We're going to find the 70th percentile. So K is 70. I is my index, which I'm going to calculate. It's K over 100, so 70 over 100 times N plus 1. So it's 70% of 30, which is 21. So 21 is an integer, and the data value in the 21st position is 64. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 64. So that says the 70th percentile is 64 years. Being able to write it out in words is important. So let's calculate the 20th and the 55 percentiles. So K is equal to 20. And I is equal to 20 over 100 times 29 plus 1. So 20% of 30 is the 6. So that means P20 is equal to the 6th position, which is 27 years old. Right there. I'm going to pause, and you're going to calculate the 55th percentile. And I'll come back and do it with you. Okay. This one is K is 55. I is 55 over 100 times 29 plus 1. So this comes out to be 16.5. So that means we're going to take the average of the 16th and 17th. So we're going to round down and round up. So the 16th is 52 and the 17th is 55. And when we average those, we get 53.5 years. Okay. Sometimes we know the percentile, but we don't know the we know the data value, but we want to find the percentile. So we're going in the opposite direction. So we're still going to order the data from smallest to largest. X is going to be the number of data values counting from the bottom of the data list up to, but not including the data value for which you want to find the percentile, but not including that. Y is the number of data values equal to the data value for which you want to find the percentile. N is the total number of data. You're going to calculate X plus 0.5 times Y divided by N. And then you're going to round down to the nearest integer. Okay. So for example, 50% of data values are less than or equal to the 15th percentile. Low percentage percentiles always correspond to lower data values. High percentiles always correspond to higher data values. So let's look at our data. We're going to the 29 ages of the Academy Award winning Best Actors from smallest to largest. And we want to find the percentile for 58. So the actor that was 58 years old, what percentile? So what percent of the actors are younger than he? So X is 18. That's the number of data points below them. And then Y is X plus 0.5. So Y is the number of data values of 58. There's only one of them. So Y is equal to 1 right there. So 18 plus 0.5 times 1 divided by 29 times 100 is 63.8%. So 58 is the 63rd percentile. You always round down on the percentiles. So last example 8, we are going to find the percentiles for the 30 ages of Academy Award winning Best Actors. So there's 30 ages now instead of 29. So we're going to find the percentiles for 47 and 31. So 47 is right here. So X is equal to 15. There's 15 data points below 47. And Y is equal to 1 because there's only one 47. And so K is equal to 15 plus 0.5 times 1 divided by 30 this time. So that comes out to be 51.7, but we always round down, so it's 51. So P of 51 equals 47. So there are 51% of the data is below the age of 47. And so for 31. Go ahead and pause and calculate this on your own and come back and check out the answer. So X equals, this time there are 8 data points less than 31. 1, 2, 3, 4, 5, 6, 7, 8. And Y equals 2 this time because there's 2 data points of 31. So K is equal to 8 plus 2 times 0.5 divided by 30 is 0.3 or 30%. So P30 equals 31 years. So 30% of the actors were younger than 31 years old. That covers lesson 3.3. Catch me back for lesson 3.4.